More often than not, we use a flowchart proof. And so first of all, we're going to define, excuse me, what a dart is. And a dart is a concave kite. So if you remember what concave means, what does it mean? It goes into, so it kind of forms a cave, right? So if I were to take this kite right here that I see right now, I'm going to kind of dent it in. So in other words, if I take like this, I've created a dart. Okay, I've caved in that one side. So that is one option I could do. I could also go ahead and work with this side, and I could cave it in that way. So that is what a dart looks like. And so we often refer to darts as, okay, four sides again. So this would be dart A, C, B, D. Okay, notice how it caves in, looks real similar to the one I just looked at. Okay, so that is what a dart is. Now, some of the properties still hold true. Okay, the properties about the kite that still hold true. These angles will be the same. Okay, what do you know about these two sides? These will be the same, and these will be the same. Also, we know that these two angles will be the same. Okay, so pretty much a lot of those properties still hold true. The property that doesn't hold true is about the diagonals. Okay, because we don't really have diagonals now that we've kind of caved that in. So that's pretty much what a dart is. Just be aware of what it is. You're probably not going to be tested over anything on that. Okay, it's just one of those things that you need to know. So let's go ahead and look at this. Okay. Given dart ADBC with AC congruent to BC and AD is congruent to BD, we want to show that CD bisects angle ACB. So first of all, what would be a starting point? Okay, AC is congruent to BC. Also, AD is congruent to BD. Now let's go ahead and look at this flowchart and kind of figure out the rationale or why they gave it to us. I see I've got how many lines here? 3, and it's going to 1. Whenever I have 3 lines going to 1, what am I always showing? 2 triangles that are congruent. Okay, that's the very thing you're doing when you have 3. So I need to look at this diagram. Is there anything else in this diagram that I can use to show that these 2 triangles are congruent? CD equals CD. And why do I know that? Same segment. Very good. So now, how do I know that those 2 triangles are equivalent? Side, side, side. So let's see where I need to go. I need to show that CD is the bisector of ACB. So if it's the bisector, what do I know? It splits it into 2 parts. So if CD is the bisector, that means it splits this angle and this angle into equal parts. So let's see, what's going to have to go here in 5?
ACB.
Oh, you got ACD to BCD, and why? CPCTC, because we've already shown those triangles are congruent.
Could you say that angle A is angle B as
The problem is you don't really know. I mean, you see it in a diagram, but since it's a dart, we haven't really, established those conjectures yet. So, let's go and look at this one. Prove another conjecture. The diagonal of a parallelogram divides the parallelogram into 2 congruent triangles. So we are given we have a parallelogram. So since we have a parallelogram, we know this and this are parallel. We also know that this and this are parallel. Okay. We also know we have a diagonal SA. We want to show that triangle SOA is congruent to AKS. So let's go ahead and see what I have in my flow chart. I already have that SOAK is a parallelogram. SO is parallel to KA, which I have marked. I also know that OA is parallel to what? SK. Reason? Definition of a parallelogram. Okay, so let's look at my next flow chart, our next step in the flow chart. 3 things. So what do you know I'm trying to do? Prove a triangle is congruent. So first of all, they tell us that 3 and 4 are the same. Okay, we know that because that's the alternate interior angle conjecture. I also know that 1 is congruent to 2. How do I know that? Alternate interior angle conjecture again because I have the side lines that are parallel. And then SA is congruent to what, folks? SA, reason? Same segment. Nice job. And so now let's go ahead and look at what I've done. Okay, I've got an angle, I've got a side, and then I've got an angle. So I know that triangle SOA is congruent to AKS. Reason? ASA. Yeah. Why is it not AAS? Or SAA? Why is it not that?
Because the sides are
The side is right in between the angles. That's right. It's sandwiching the 2 angles. So now, we're going to write one without filling in. Okay, and you'll have a couple of these on your homework today. So first of all, we need to prove that the diagonals of a rectangle are congruent. They tell me I've got a rectangle with diagonals YG and OI. Okay. So now there are various ways to do this. Okay. The first place I would start with is that you have a rectangle
Are we doing number 6 on this?
YOGI. Don't know. Reason? Given. Okay, so now let's see where we need to go. We eventually want to show that YG and OI are the same. So let's think about things. If I want to show that they're the same, I probably want to do something with triangles. So I may want to show that I've got a triangle here, and maybe that triangle is the same as this triangle here. So you see how that kind of works? So let's think about those triangles and what we know based on the fact it's a rectangle. Do I know anything else about sides, angles, anything?
I
90.
That's what you're trying to show.
GI
IO
equals
is
OI.
Okay, what'd you say?
GI is congruent to OI.
GI is congruent to OI. Why?
On definition.
That's if you remember, the opposite angles in a parallelogram are congruent. Same thing with a rectangle. Okay? So I know those 2 are the same. What else do I know is the same?
GI.
IY is the same because it is a same segment. Okay, what else do I know? I don't know anything about that third side because that's what I'm trying to prove. Do I know anything else? Not in a rectangle. Okay, in a rhombus they bisect the angles, and in a square they bisect, but not in a rectangle. What else do you know? You're on the right track though. That's where you need to concentrate on what.
IGY.
They bisect each
GY is
GIY is congruent to IYO.
Why? Why are these 2 congruent? They're what? 90 degrees. Aren't they each 90 degrees? Okay, and a rectangle, those are the same, right? So let's look. Here I have a side, here I have an angle, here I have a side. Oh, so there we go. So let's go ahead and start with our first statement. Our first statement, GI is congruent to OY. Oh, not Q. OY. Why?
Definition of parallel.
Okay. So could I just go ahead and sub in rectangle since they said it was a rectangle? Okay. So there's one. What else do I know?
IY equals IY.
IY is congruent to IY. Reason?
Same segment.
Same segment. And then what else do I know?
Angle GIY.
Angle
is
GIY.
congruent to OYI.
Okay, is congruent to OYI. Why? Definition of rectangle. Okay. So then now I've got 3. So where do I go from 3?
To a triangle.
To the triangle. So triangle, let's just go GIY, is congruent to triangle what? OYI. What's the reason they're going to be? SAS. So now we have to do our little arrows going to that. And then last but not least, what do we have?
YG equals OI.
YG is congruent to OI. What's the reason there? CPCTC. So see, it's not that bad. As long as you show your steps, basically, take that diagram, write down everything you know. Okay? A lot of the times you're going to have to prove triangles are congruent. And so that's a great place to start. Questions? All right, you have 6 problems for me on pages 300 through 301. Okay, 6 problems. Remember your test you're shooting for Wednesday? Okay, test Wednesday.